And
Do they work on similar processes as we understand the brain to work, or is this something much different?
they are quite related. So they have individual neurons that work in a semi-random way, and they have potentially thousands of these neurons and millions of connections, and they train them by applying lots of data and finding um, gradually that these layers can be self-organized mostly, and then trained with some labels for the data to actually just narrate the representations it's got to really clue onto specific features of images. Um, and and one of the great things about these neural networks is that you can actually say, well, I want to see what you think an image of a cat is, and activate a cat at one end, and then it can spontaneously generate an image of a cat.
Mm-hmm.
And that's similar to what happens in our minds.
The thing that's really interesting about it is that if you can create a synthetic neural network that responds to input in the same way that ours does, it's still going to require that our physical input from our sensory organs and our senses through the central nervous system to the brain, feeding it all the time with this sort of stimulus and data. It's still the sensation of putting your hand on something and touching it, or feeling a baby's hand on your face. The actual sensation itself is interpreted by your sensory apparatus, and your central nervous system sends it to the brain, and the brain interprets it. So it's so easy to want to say that we could artificially recreate those conditions and send the same sort of to a neural network, and that thing is going to somehow be the same as the actual skin sensors on your skin receiving the tactile information that's being sent to the brain, and the brain interpreting it. And after millions of years of evolution providing us with those abilities, we're just going to figure out how it does it and then just put it into a machine and it's going to work. I'm saying that's the interesting thing, that for somehow we think that we can simply reproduce the physical structure and create the process and algorithms which simulate the way we receive data in our brain, and it's all just going to coalesce into this guy who's going to pop up and say, "Hey, what took you so long to create me?"
On that score, I mean, I think that, I don't know what your feelings are about this, Toby, because I think this is just the engineering hurdles seem very high, and they're especially higher than someone like Ray Kurzweil or something would give us any indication of. Like, we really don't know how the brain works. Like, we're really not we haven't quite figured it out. And you see this this brain project that Barack Obama announced and stuff. It's an attempt to pour a lot of money in that to try to figure that out. But we're not really anywhere near that. And we'll need to do that in order to be able to translate this into some kind of AI. And then on top of that, we're not only going to need to know how the brain works, but we're going to need to know how to replicate that using kind of subsystems that aren't biological. So it's we got a number of hurdles in front of us, and then even after that, I think we need to figure out how not only how a conscious being would interact, but kind of its interactions, how it negotiates its interactions with other things. We're a long way from even making an artificial dog that could relate to you like a real live dog. It's just the hurdles are a lot higher, I think, than some in the singularity community would have us believe. Right? Am I right?
Yeah.
Okay.
There are certainly some hurdles.
Okay. And then I guess this kind of wraps to Jim. Jim, is it your view that if let's say we did understand how the brain worked, we knew it, we figured it all out, would we be able to then do you think it's pretty clear that we would be able to then replicate the kind of consciousness you see in human beings in some kind of machine?
Well, I think we have to back up a little bit here, and I think I have to kind of separate out two issues. Okay.
Okay.
Okay. One issue is whether or not we could take through software programming, neural networks, or whatever means in the future comes about, whether or not we could create a reasonable facsimile of a dog or a person, something that would be so real to us that we would infer that it has consciousness. Okay, that question is, I think, yes, that'll happen. That will happen eventually. Okay, there may be, as you mentioned, engineering hurdles to do that, but I think eventually that we will be able to accomplish that. Now, the other question is, will that entity or that we create actually be conscious? And that's where I would tend to say no. Okay, although there is the problem of, well, I don't know that it's not conscious, right? Just as I don't know you're conscious, right?
Right. The problem.
Yeah, it's the same problem. But my belief is that consciousness is somehow tied directly to I'm getting some echoes here. I don't know whether you're hearing them or not.
Yeah, the one thing you can do if people get echoes, like what I've found to do this, is like if people who are not speaking, if you mute your microphone, like that'll cut back on any feedback, or it should.
But what I believe is that I believe that there is something definite about the carbon atom and the molecular structures that it's able to form, that is able to produce the subjective sensation of consciousness. And I'm not sure I have a firm scientific basis for that statement, but I certainly believe it. I believe that's true. And if that's the case, then the only way we could produce a truly conscious entity would be basically to produce a carbon-based entity that's probably based very much upon the similar molecular structures that are in life forms. And if that's the case, if that's the case, I would argue that we've basically just created another living entity, and yes, it could be conscious.
Let me ask you then what you think about this thing I've heard of recently. Like they recently, I guess that they have you ever heard of the artificial hippocampus? I don't know if you've heard of it. Basically, it's the hippocampus is a part of the brain that's responsible for basically memory, right? It's not so much a place where memory is located as it's kind of like a sorter, and it sorts where memories go.
For the formation of memory.
Yeah, and what they did, scientists have no idea how the hippocampus works. All they know is that it has this grid-like structure. It's structured like a grid. So what they did is they replicated that grid, not with biological materials, but with some kind of bioelectronics. They replicated that, and then they put it in a person's head, right? Who had I don't know, damage from the hippocampus from a stroke or from an accident, I don't know what, and it worked. The person, their memory worked their memory went from dysfunctional to back to normal. So it's it's obvious. At least if that kind of rule holds true, there are at least parts of the brain can be its architecture can be replicated by a machine. So it's obviously that. So I don't know how that. I don't know how you would answer that, Jim. Like what do you think's going on there, or whether or not you think that detracts from your view or doesn't.
Well, I think I'd have to see the actual study,
okay.
See what they actually did, right? It's obviously you can put in artificial hearts. We might be able to produce some sort of artificial liver or something in the future too. I mean, it's true you might be able to replace certain organs and certain discrete pieces of functionality. Whether or not that will lead to, whether or not that means that you can replace everything is another matter.
Right. And, you know, I mean, it's even possible that we may find that we need some kind of biological components. And, you know, I mean, it sounds kind of Frankensteinish, but we might, you know, actually make a machine that has partial biological components, right? You know, that somehow replicate things in the brain that we can't necessarily replicate in machines. That seems like a possibility.
The new